Hello. In this video, I will show you how I approach and attempt to solve a technical issue with a DVR. The main problem manifests as the random stopping of the recording function, which affects the proper use of the device. Specifically, after disconnecting and reconnecting the power supply, the DVR starts functioning again, but only for a limited period of a few days, after which it locks up once more. We'll analyze the possible causes of this issue, perform measurements and technical checks, and finally, I'll try to find an effective solution to fix it. A DVR, or digital video recorder, operates by capturing video signals from surveillance cameras, compressing the data using codecs such as H.264 or H.265, and storing it on a hard drive or other storage medium. Its proper functionality depends on several components. Power supply unit provides the necessary voltage to internal circuits. Any fluctuation can cause issues. Processor and memory handle real-time processing, storage, and playback. Overheating or software errors can lead to system freezes. Hard drive, responsible for data storage. If it's worn out or defective, recordings may be affected. Firmware, the operating system that coordinates all the DVR's functions. Corruption here can result in errors. First, I will power the DVR using its original power source to check if it functions properly with the existing power supply. After connecting it to the power, I will connect a desktop to the DVR using an HDMI cable. This will allow me to directly monitor the video signal processed by the DVR on the screen and check if the recording function is active and if the device responds correctly to playback commands. By using this HDMI connection, I will be able to quickly identify any issues with the video signal or its processing. If I encounter difficulties or freezes, I will immediately know where to focus in order to resolve the problem. This test will be essential for evaluating the initial functionality of the DVR before replacing any components. Unfortunately, I don't have a wireless camera on hand at the moment to check the video signal directly, but don't worry. Even without it, we can still take important steps to test the DVR. I will connect the DVR to the power supply and to a desktop via HDMI cable to check the overall functionality of the system. Even though we can't view the image from a camera, we can still test the device's response to commands and check for errors in the recording process or other technical issues. So, stay tuned, as we will continue to explore solutions and diagnose the issue further, even without active video signal. While I prepare the connections and get ready to test the DVR, I want to emphasize how important it is to approach each step carefully. Even without the camera connected, the entire diagnostic process for the DVR is essential to understand the potential causes of the issues encountered. For example, unstable power supplies or software errors can cause unexpected recording stoppages. It's interesting to see how sometimes a seemingly simple problem, like a faulty hard drive or a weak power supply, can have significant effects on the performance of the entire security system. So, even preliminary tests, without an active video signal, can provide valuable insights into the overall condition of the equipment. Moving forward, we will explore further possible solutions to resolve any issues encountered, so that the DVR can function correctly and steadily. With the risk of repeating myself, I will try to be as clear as possible so that everyone understands it better. The first step in eliminating the cause of the issue will be replacing the hard drive. The hard drive is the primary component responsible for storing the video files recorded by the surveillance cameras. In a DVR system, the performance of the hard drive is crucial for the overall operation of the system. Any issue with the hard drive, such as bad sectors, mechanical wear, or low performance, can lead to interruptions in the recording process or even a complete system freeze. These problems can prevent the DVR from recording continuously, which is essential for a functional security system. Therefore, replacing the hard drive with a tested and fully functional one is one of the most effective ways to solve this problem. By doing so, we eliminate one of the most common causes of performance issues and ensure smoother operation. A typical DVR receives the video signal from the surveillance cameras and processes it through a video compression algorithm, such as H.264 or H.265. These compression technologies reduce the file size while maintaining an acceptable level of video quality, which makes it possible to store more data within the limited space of the hard drive. The compressed video files are then stored on the hard drive for later access. This process is essential for any DVR system, and a faulty hard drive can disrupt this sequence, leading to data loss or corruption. The main processor of the DVR handles all these operations, compressing the video data, writing it to the hard drive, and playing it back upon request. Additionally, the processor ensures that everything runs continuously and without interruptions. If there's an issue with the hard drive, such as slow write speeds or damaged sectors, the processor will struggle to manage the data flow, which can lead to freezes, system crashes, or corrupted recordings. Once the hard drive is replaced, the system should resume normal operation, allowing it to store files properly and eliminating write errors. Moreover, the power supply plays a crucial role in ensuring the DVR operates as expected. It provides the necessary voltage to power all the internal components of the DVR, including the processor and hard drive. If the power supply isn't functioning correctly, for example, if it doesn't provide a constant voltage or if there are fluctuations, the DVR may experience instability. Combined with a faulty hard drive, this instability can cause the recordings to stop suddenly or even result in a complete system failure. Therefore, replacing the hard drive and checking the power supply are essential steps in eliminating the most common causes of random recording interruptions and system freezes. In addition to these basic components, it's important to remember that the firmware and software running on the DVR also play a significant role in its stability and performance. Corrupted firmware or software errors can sometimes mimic hardware issues, making it difficult to determine if the cause of the problem is related to the physical components or the system's internal code. Once the hard drive is replaced and the power supply is checked, it's worth considering an update or reinstallation of the firmware if the issue persists. By replacing the faulty hard drive, checking the power supply, and ensuring that everything is working as it should, we address the most likely causes of the recording failures. These steps will restore the DVR's stable performance, allowing the system to function properly and continuously over long periods. This will ensure that the video data is stored securely and is available for future use. Security systems are only effective if they work consistently, and with proper maintenance and upgrades, we can ensure that the DVR continues to operate well over the long term. Stay tuned, because after these replacements, I'll show you the process of verifying and ensuring that the system is fully operational. As seen, the hard disk I installed is functional, and now I will proceed to format it. Formatting is an essential process that prepares the unit for use in a system. In this case, formatting will erase all existing data on the hard disk and create a new file system, allowing for the storage and organization of video files from surveillance cameras. Technically speaking, when formatting a hard disk, the system creates a structure of directories and files to organize the data on the disk. For DVR systems, the file formats typically used are NTFS or XFAT, as these formats allow for efficient storage of large files, such as video files. The formatting process involves several technical steps. Erasing old data. The first step is to remove all files from the hard disk, thus freeing up space for new files. While the data is not completely destroyed, this step is sufficient to make room for the video recordings. Creating a new file system. Once the old data is erased, a file system compatible with the DVR's requirements is created. It organizes the data into sectors and marks the areas available for writing. Checking the unit's integrity. In this step, the system checks for bad sectors or other physical issues with the hard disk. If errors are found, they may affect performance and storage capacity. Allocating storage space. After the file system is created, the hard disk is ready to store video files. The DVR will organize recordings into time intervals and overwrite older files as space fills up. It's important to note that formatting does not guarantee the hard disk will work perfectly in the long term, especially if there are bad sectors or other physical issues. If formatting doesn't resolve the problem, we may need to test the unit in more detail or replace it again. In conclusion, formatting is essential for preparing the hard disk in a DVR system, ensuring clean and efficient storage of video files. After formatting, we will check whether the unit is working correctly and whether the DVR can store files efficiently and without issues. Next, we will check both power supplies to make sure they provide the correct voltage and polarity required by the DVR. Power supplies are essential for ensuring continuous operation of the DVR's internal components. First, checking polarity is crucial. If the power supply's connections are reversed, it can cause severe damage to the DVRs. Internal components. Typically, the power supply will have a positive plus symbols and negatives minus symbols pin, and it is important to ensure these are connected correctly. Equally important is the voltage. DVRs typically require specific voltages, such as 12V or 24V. If the voltage provided is too high or low, it can cause instability, interruptions in recording, or even permanent damage to the DVR. To verify both aspects, we will use a multimeter to check the voltage and polarity at the output of each power supply. If the values match the DVR's required specifications, the power supplies are considered good. If not, we will need to replace or adjust the power supplies accordingly. By ensuring the correct voltage and polarity, we prevent power-related issues and ensure that the DVR will operate smoothly and reliably over time. The next step will be to send the DVR along with another power supply for testing. This will involve checking the full functionality of the system and ensuring that there are no fundamental issues that could affect its performance. By conducting prolonged operational tests, we can identify if there are any additional hardware or software issues that might cause recording interruptions or system instability. I will specify the results obtained in the video description later. That's it for today's video. If you found this content helpful, please give it a thumbs up, subscribe to the channel for more technical tips, and share your feedback. It's always appreciated. See you in the next video.